In our video today, we're going to be taking a look at mixture problems. These are a pretty particular type of story problems where we have two sets of things or two sets of information. We mix those together and then we get a resulting thing at the very end. So we're going to go through a couple ways that we can set this up and prepare this for ourselves, but I do want to at least note a suggested strategy that the book recommends and I think is also reasonable to use with a lot of story problems in general. So a couple things I want to note if you are choosing to write this down for yourself is between these two parts here. I'm actually going to do the second part in red. Let's stand out a little bit more. There we go. So if we're looking at our information here, we're told to read, reread, and reread the problem and do this as much as we need to throughout the whole process. Make sure you really know what's going on and you go back and verify what's going on in the problem as much as you need to. You want to identify relevant information and what specifically we are being asked to solve for. A lot of people will just read a sentence or a paragraph of stuff once and then just start solving for random things and not actually doing what the problem is asking. That can get us into a lot of problems because we might find a correct answer but answer a completely unrelated question from what the problem gives us. I also think it's very important to label variables and numbers accordingly if you are writing them down somewhere on your paper. A big hint I have to you with this, and in this part in particular, look for units. The number 5, what does the number 5 represent in a problem? Is it a dollar amount? Is it gallons? Is it miles per hour? Is it walruses? What is the number 5? So we want to make sure that we are using and paying attention to units in these types of problems. I think those are very, very helpful in seeing what information is and isn't relevant to what we're solving for as well. Next thing I would recommend that we do is set up a visual, and we're going to use tables and buckets for visualizing these things. For me personally, if you're in my class, I do not care which of these two methods you would like to use to visualize these things, but I would recommend using one of them, or maybe you develop and use your own way of visualizing this set of information to organize it. I'm fine with that too. But I think a visual is great because it lets us see what's happening in general, and then we can fill in necessary information with labels to organize what we've been given and see how it all might, interact with one another and go together. It's only after we've done all of these things that maybe we start setting up equations and we adjust those equations accordingly. There's nothing wrong with writing out something in a general form, and then maybe in the next line, I'm going to modify it and make it a little bit more accurate to the problem, and then the next line, I revise it and make it a little bit more accurate again, and so on and so forth. A lot of people want to avoid that and just put the one single correct equation down at the beginning, and while I think there's good intention behind that, there's nothing wrong with taking a couple lines to put an initial thought down, then revise it and revise that. We do that in our head anyway as we're thinking through these problems, so why not do that on our paper as well? So all of these, which I think are the hardest parts with all of these problems, but note that all of this is the setup portion of these mixture problems. And yeah, it's the hard part with this. There isn't an exact science and an exact way that you need to do this every single time. And I think that's where it gets a little complicated and tricky for people. So take the time that you need to worry about the setup and make sure you know exactly what's going on and what you're creating for yourself. After we've done that, we can go through and actually solve the equation that we prepared, and we can use any of our previously learned methods to do that. This is the section where we actually do math. And we can check our answers to see if they are reasonable within the context of the problem. A reasonable answer would be something like, I have some amount of pennies and some amount of nickels mixed in a bag or in my pocket. And if we go through and find an answer to be the number of pennies is 5 and the number of nickels is -20. Does that seem reasonable and make sense? Well, no, it doesn't. I couldn't have a negative number of coins in my pocket. That's just an unreasonable answer. That would mean I need to go back and maybe check how I solved the problem, or check my setup, make sure that I have everything properly created for myself. So if you're following along with the textbook, they do have some examples on using tables, and more of those on page 330 to 342. We have 5 examples here, and I'm going to go through one of them using the table, and then the rest of them I am going to use a bucket for. This is purely and entirely personal preference, as I find the buckets as a better visual for me to keep track of two things or two sets of things mixing together, and that just clicks for me a lot more. But again, you're welcome to use either of these visualizations. You will see that they are very, very similar to one another, and there isn't a whole lot of difference in them. So we'll go through and show you our 5 examples here. If you'd like to pause the video at any time to write these down for yourself, feel free to do so. We're also going to take a look at each of them individually as well. So let's go ahead and dive into our first one and get going with these. For our first example, we are told that Morty has $2.10 in nickels and quarters in his backpack. He has 12 more nickels than quarters. How many coins of each type does he have? So a couple things that we want to note here. We want to note the units that we are going to be working with, the types of things that we are working with, and a result. So it looks like we're working with nickels and we're working with quarters. We're also working with a grand total number and value that we have, and some relationship between the nickels and quarters in this problem also. We're also asked how many coins of each type does he have. So we are not trying to find the value that he has in nickels and the value that he has in quarters. We're trying to find out how many physical coins he has that are nickels and how many coins he has that are quarters. So it's very useful in keeping that in mind and being kind of picky with how we define units like that. Let's go ahead and make a table for ourselves and make a visual of this thing. So we have nickels, we have quarters, and we have a result. I think the result is always a good starting place, but we want to make sure that we're clear that we have 3 things potentially mixing here. So we have information here, we have information here, and we have some information at the very end. So I always like putting the result at the very end, because this is always going to be present in these mixture problems. So the result, the total, the outcome, something similar to this, but I'd recommend having this label at the very end here for this last column. Now we have 2 other things that we need to fill in here. What are the things that are mixing together? Well, I'm mixing nickels and I'm mixing quarters. We'll dive into more specifics about these and the result in a second, but we have nickels and quarters that are mixing together. So I'm going to go ahead and write those in. Just do it shorthand here. But you want to write in nickels, quarters, just so we know nickels mixing with quarters. Some people like to put a plus here. Equals my result. So now I want to dive into some specifics regarding nickels, quarters, and our results here. So those 2 parts are this. We are asked and given some information about how many coins of each type does he have. And we are asked about a dollar amount or a value here. So I would say one of our units for this is going to be the number of coins. You can shorthand this. We're just going to have the number of coins that are nickels, the number of coins that are quarters, and the total resulting number of coins when these things mix together at the very end here. We also have a part down below because we always have 2 units with these. So we have number of coins. This is also sometimes referred to as an amount. It's a pretty common way of thinking on this. Amount shows up quite a bit with this. So the amount is the number of coins. And then we have a value, these things written in here as well. So I have an amount and I have a value. Now, what value are we working with? Are we working with euros? Are we working with pounds? We're working with dollars here. So again, make sure we have that written out. We have it very clear for ourselves that we're working with a dollar value. Now we can start filling in information in this problem and filling in these boxes here. So what's the value of a nickel in terms of dollars? Well, that's going to be $0.05. Quarters are $0.25. And our result, well, what's the resulting amount that I have? Well, I've been told I have $2.10. Okay, so my result is $2.10 here. Perfect. So we just filled that in, kind of some common knowledge or maybe information that's been given to us. Now, what do I know about the number of nickels and the number of quarters? Well, I don't know either of these amounts specifically. However, I have been told in the problem that he has 12 more nickels than quarters. So that tells me that if I know the number of quarters that Morty has, the number of nickels is going to be the number of quarters plus 12, because we're told he has 12 more nickels than quarters. So it's the number of quarters plus 12. Now, do I know this total resulting amount? No, that has not been given to me in this problem. However, what's nice about this amount row here is this amount of coins plus this amount of coins would give us a result here. So what's the total number of coins? Well, it's going to be 2Q plus 12. We may or may not be using this as we're creating equations, but sometimes it's nice to have that written in there just to know the amounts added together should give me my result here. And I think the trickiest part with this particular problem is figuring out, hey, what's the relationship between the number of nickels and the number of quarters that I have? That tends to be the tricky part with those. So be careful with how you're setting those things up and how you are interpreting the information that's been given to you. But now we want to go through and make some equations out of this, or an equation out of this. The way we do this is we take the amount and multiply it by the value. I have this number of nickels and I multiply it by the value of each nickel. I have this number of quarters and I'm going to multiply it by the value of each individual quarter. So off to the side here, I'm going to write that in for myself. I'm going to have the amount times value plus the amount times value. Now the common knee-jerk reaction is to say, well, I'm then going to multiply the number of coins, the total number of coins, by the total value. And this is where we have to pause on this. This is an amount, or this is a value of all of the nickels. This is the amount of the value of all of the quarters, and I should be getting a resulting amount in value here. So this is only going to be the $2.10 at the very end. So when we work with these mixture problems, if we're working with value, the resulting value is generally what we end up with our equation. So we multiply amount and value, and the result is just the resulting total value. And at this point in time, great, we have an equation that's written out for us. This looks like one of the mechanical problems we saw in Chapter 2. We can go through and solve this thing like we would normally. So I'm going to distribute this 0.05 through to everything inside here. So from here, I'm finding out that I have 5 total quarters. So with that, I've been asked about how many of each type of coin do I have. So if I know the number of quarters, well, what do I know about the number of nickels? We're told he has 12 more nickels than quarters. We also have that written in right here in our table. So to find the number of nickels, We just take this 5, we add 12 to it. That gives us 17. So our final answers for this is that we have 5 quarters and we have 17 nickels. With our second example here, I'm going to show this using buckets to visualize these things mixing together rather than a table, but you are more than welcome in your problems to use either method that you would like. I'm not, in my class, going to be requiring that you use one method or one organizational structure over the other. It's entirely your choice. So with the second problem, we're told Summer has $6.55 worth of quarters and nickels, should be in her purse. The number of nickels is 5 more than 2 times the number of quarters. How many nickels and quarters does Summer have? So making a visual of this, I have nickels and I have nickels and quarters that are mixing together. So the visual with the buckets, again, this is my personal preference. I really like this one. I have a bucket of stuff plus a different bucket of stuff equals some different final bucket of stuff. So I have something mixing with something else equaling something at the very end. Now, like we did with our table, we do need to label these things. And I think result at the very end is always a great starting place. So I have my resulting number of, I don't know what here, but I have a result here. Now, what are the two things that are mixing together? I have quarters and I have nickels that are mixing. So I'm just going to go ahead and write that in and label that. This is all the information that relates to quarters. And here's all the information that relates to nickels. Now, like we did with the table, we need to have some information that's going to be inside the buckets. And then we have a second row, which we're going to put just right below the buckets. For me personally, I always like putting the amount of something right here to label inside the bucket. I could visualize an amount of stuff inside of a bucket. I could visualize what, 10 quarters looks like, or 50 nickels, or something along those lines. So I'm going to write in the amount. The amount right here. And the amount, what unit am I using to track an amount here? Well, for this, I'm tracking the number of quarters or the number of nickels. We're asked how many nickels and how many quarters does Summer have. So I just want to know how many physical coins that are quarters and how many physical coins that are nickels does she have in total. So I'm just putting the number of coins in here. Now below this, we need to also determine what is the value of each of these buckets as well. Well, this first bucket is representing quarters. So what's the value in dollars of a quarter, of a nickel, of my result that I have right here? So great, we have our 5 labels set up. And we should be noticing that this setup pattern is very similar to the table that we worked with. If you wanted just a quick reference for it, I'm going to do this in red, but I'm going to erase these lines here afterwards. Notice how similar this is to our table that we used previously. It's almost the exact same thing, but just a slightly different variation on how to visualize this. So again, nothing particularly new, but we still need to go through the same setup and organize and label everything the same. But now we can start filling things in. Each of the buckets should be filled with something, and the value right below the bucket should be filled with something also. I think the result is always a good starting place. So what's the value of the result? Well, that's going to be $6.55. What's the value of a quarter? That's going to be 25 cents, so $0.25. A nickel is $0.05. Okay, so we have our values filled in here. Now we need to start filling in the number of quarters and the number of nickels. We were given some information about this right here. And it states the number of nickels is, remember back to 3.1, is corresponds with an equal sign. So if I'm trying to figure out the number of nickels here, maybe I could write this in something like this. The number of nickels equals, and now everything that would be to the right of this, I'm just going to write it down below because I'm running out of space here, is going to represent everything that comes after this. So we're told the number of nickels is 5 more than 2 times the number of quarters. So we have more than telling us that we have addition, and we have 2 times telling us that we have multiplication. So what's going to be coming first? Am I going to have 5 plus 2 times the number of quarters, or 2 times the number of quarters plus 5? This is where order matters with these things. So we're going to have the number of quarters, or 2 times the number of quarters, I should say, and then I'm going to add 5 on top of that, because I need to know this amount of quarters, and then I can tack on 5 on top of that there. We've been given nothing special and other information about the number of quarters, so we can just fill this in with a Q instead here. Now with this, I'm using Q and N as my variables. You could just as easily use X and Y if you'd like to. I personally like to choose a variable that kind of corresponds with what I'm solving for, but that's just me, that's my personal preference. Now what should my resulting amount be? Well, the number of quarters plus the number of nickels in terms of the number of quarters means that I should have 3Q plus 5. Okay? So perfect. So we have our setup here. We have all 6 portions, 1, 2, 3, 4, 5, 6 filled in. Now we can start making an equation out of this. Remember that we are going to take the amount of quarters times the value of quarters. The amount of nickels times the value of nickels. So we're just going to write those in here. And remember that if we are working with dollar amounts, the resulting thing over here is not going to be the amount of coins times the total value. It's just going to be the total value. So from this point, we have our overall equation set up for ourselves. We can solve this thing using all of our previously learned methods. From here, we are getting that we have 18 total quarters showing up this thing. Now, we need to figure out how many nickels do we have. Well, thankfully, we already have an equation set up that's going to solve that for us. We had right at the top here, the number of nickels is equal to 2Q plus 5. Try and zoom this out just a little bit. Maybe I can get it all on the screen. There we go. So the number of nickels is going to be listed right here. So I can just do 2 times 18 plus 5. So that's going to give me 36 plus 5, and that's going to give me 41. So I have 18 quarters, and I have 41 nickels. Looking at our third example, we are told the band Metallica sold 115 tickets for a total of $1,163 at a small local venue show. General admission, GA, tickets cost $5 and seated tickets cost $12. How many GA and seated tickets were sold each? So we have two things that are mixing together here. We have GA tickets and we have seated tickets, and we have some information that goes along with each of those. Again, I'm going to use the bucket method, I should say, for setting these things up moving forward, but you could just as easily use the table if you would like to, or maybe try a different method if you're really feeling inclined to try something else with these. Lots of options, or just pick one and commit to it. So we have two things mixing together, and then we have a result at the very end. We have GA tickets and we have seated tickets. So we're just going to put a little GA and seated in here. It doesn't need to be super elaborate, but some way to tell this is the information related to the GA, the general admission tickets, and this relates to the seated tickets. Then we need to have something off to the side here, more units. We always have an amount of something. Again, I like putting the amount inside the buckets. And what is that amount? Well, the amount is listed as the number of GA tickets and the number of seated tickets. So really just the raw number of physical tickets that are for each of the different types of seating that we could have. So I'm just going to put number of ticks in there for short, number of tickets there. What else do we have? We need to have the value written in here as well. What's the value of each of the seat types and the total resulting value that came out of the show? And we are tracking that value using dollars. Again, as it's given to us in the problem, $5, $12, $1,163. So we have that little hint there for us. Now we can start filling things in each part of our setup. So for the GA tickets, we're told general admission cost $5. Okay, we can put 5 in here. Seated tickets cost $12. Those can go in there. The result, what was the resulting value or the total amount of money that came out of this? Well, that's this 1,163. We can fill that in here. Now the tickets, the total number of tickets and the amount that we have, this is where it gets a little bit tricky. Do I know the total resulting amount of tickets that were sold? Yeah, that tells me right up here there were 115 tickets that were sold. So I can fill that in at the very end. Now I don't know any specific information about the relationship between the number of GA, general admission tickets, and the number of seated tickets. I don't know anything about seated tickets are 5 less than double GA, or GA is 18 more than half of the seat. I don't have any information like that showing up in this problem. So our only alternative with this is to basically say, all right, if I knew the number of general admission tickets, let's say it was X tickets, well, how many seated tickets would I have if the total is 115? Well, I would have the number of general admission plus the number of seated would give me the total result here. It's a reasonable assumption that these could add together. We can also go in the reverse of this by saying, well, the number of seated tickets is the total number minus however many are the general admission ones. But this effectively says the leftover tickets that aren't general admission are going to be the seated tickets here. So it's this resulting total minus whatever the general admission tickets are. That's just going to fit in right here. Now it should be noted, you could have the general admission be X, you could have the seated be X, and then have the 115 minus go for either of these. But just make sure you're just establishing this one is going to be my X or this one's going to be my X up front. Once you've done that, then you have that flexibility of assigning the other one to be the resulting or leftover amount. But what's great about this now, I have every single thing filled in my visual. I can now start making an equation. So this is going to look like this. And remember, whenever we are working with values, specifically with dollar amounts or just values in general, we are not multiplying the amount, the resulting amount, times the resulting value. We just use the resulting value here. So amount times value for the first thing plus amount times value for the second thing equals just the resulting total. And from here, we're just going to solve this like we have all the problems we did in Chapter 2. So I'm getting x equals 31. What does x represent in the problem? X represents the amount or the number of general admission tickets. So great, I have my general admission. I now need to find the seated tickets. And we have that written out right here. We have this 115 minus x. So we have seated is going to be 115 minus 31, the value that we found there. And that's going to give us 84. So we have a total of 31 GA, general admission seats, or tickets that were sold, and we have 84 seated tickets that were sold. Now our fourth example is going to have a slight twist to these setups and the equations that we're going to be creating out of them. 4 and 5 are both going to have this, so I want to make sure we see the subtle differences between these, and it's all in the wording and information that's been given to us in the problem. So we're told with number 4, Rick is mixing nuts and cereal squares to make a party mix. Nuts sell for $7 a pound, and cereal squares sell for $4 a pound. Rick wants to make 30 pounds of a party mix at a cost of $6.50 a pound. How many pounds of nuts and how many pounds of cereal squares should he use? So, similar to the other ones, we are still going to be making our visual and our setup for this. Again, I'm still going to be using the buckets for this because I think that's, again, easiest for me, but you use whichever method you want. We have our result at the very end. And then what are the two things that we're mixing together here? We have nuts and we have cereal. I'm going to go ahead and put nuts here and cereal here. We still have the amount, so how many of each of these are we mixing together? We want to figure out what is the unit we are using for amounts. And in this case, we're told, looks like 30 pounds. That tells me my unit of amounts there. So I'm going to put a little amount in pounds. Fantastic. So we know what we're looking for there. Now, here's where the tricky part comes in with these particular ones. Our value that we have with this is no longer simply just dollars. The subtle units within here are $7 a pound. Also could be written as $7 per pound. This means our value is also a little bit of a rate in here. So I'm going to put a little bit of rate in with this. This is going to change a little bit of how we create our equation, our final equation in this problem. So be on the lookout for the difference between $7 versus $7 a pound or $7 per pound. Rates make these things a little bit different as we're going through them. So what unit are we going to put in here? This is going to be dollars per pound. You can actually just do it like that. Dollars per pound. So a bit of a shorthand, but that's still important because our value is a rate based on the number of pounds that we have. So now we can start filling these things in. So how many do I have, or let's go with our value and our rate. We want the resulting thing to be $6.50 a pound. So our rate is $6.50. Our resulting amount is going to be 30 pounds. Looking at the nuts and cereals, what's the rate for each of those? Well, the nuts sell for $7 a pound. The cereal sells for $4 a pound. And now I need to determine what's going to go in for nuts, what's going to go in for cereal here. So we have the choice again. We've not been given really any information about the relationship between these two things. So we need to basically label one of these as a variable and say that the other is just going to be the leftover amount. I believe I used the first bucket here as the variable for example 3. So I'm going to go ahead and say that cereal is our variable here. How many pounds of nuts am I going to use? Well, it's going to be the total amount minus the amount of cereal that I have. So the nuts is just going to be the leftover for this particular problem. But again, you could reverse these if you really wanted to. It's your choice. Just pick which one is going to be the starting thing and which one's going to be the leftover, and then just commit to that. Now the part that's going to get a little bit tricky, and here's where the main difference shows up in these types of problems versus the other three that we've been doing up until now. Because we have the value as a rate, we are going to also be multiplying the resulting amount times the resulting rate also. So every single thing multiplies together here. And again, the reason for this is because the value is linked to being a rate as well. Something per pound, something a pound, dollars a pound, some dollar amount or some cost per pound with this. So be on the lookout when you're typing in or writing in the value or anything here. Has that been given to us as a rate, something per something else, or just as a flat value like we saw previously, which is just $3 or 25 cents or something to that effect. But after we have this set up, now we can go through and just solve this thing like we did with all of our previous problems. Okay, and we're getting that we are going to have 5 pounds of cereal showing up here. So let's go ahead and take a look at finding the amount of nuts that we're going to have. So we already have the amount of cereal. We know the nuts is going to be 30 minus however many pounds of cereal that we have. So we can write this in for ourselves. Nuts is going to be 30 minus 5. That's going to give us 25. So I know I'm going to have 25 pounds of nuts, and I'm going to have 5 pounds of cereal. Our fifth and final example that we're going to go through here has us working with percentages and concentration amounts. This is the type of mixture problem that I think is the most complicated for students and the one that has the most potential for really weird, random, and completely useless information showing up. So we'll take a look at this in a scenario where we can see useless information and also figure out how to deal with that. So number 5 is asking us and telling us, Victoria is creating the perfect creamsicle soda by mixing 2 different soda brands together. Brand A is 25% orange soda, while brand B is 100% orange soda. She's determined that the mixture of 24 fluid ounces contains 80% soda. So, how much of each brand will Victoria need to mix together? So we're told something about the final resulting thing here. We want 24 fluid ounces, that's 80% orange soda. Awesome. Now in the initial problem, we were told brand A is 25% orange soda. Do we know what the other 75% of that brand A stuff is? No, we have no idea. It could be, maybe we have it written in the problem, I just have it off to the side here. Maybe we're told brand A is 25% orange soda, 60% cream soda, and 15% Sprite. So it's got a bunch of stuff that's mixed in here. Maybe there are more percentages of things, maybe there's less, but it could have some extra, and it does have extra stuff written in there. So how do we deal with this? How do we deal with problems where we have percentages and extra percentages or different percentages showing up in these problems? Well, let's start with making the same framework for ourselves, either a table or using the buckets. We'll get to how we deal with that afterwards. So we still have one thing mixing with something else equals a result here. Now we've been told that our 2 things that are mixing are brand A and brand B. So I'm just going to label those accordingly. So I have brand A here in the first one, and I have information about brand B here in the second one. I still want to work with and determine what the amounts are with these things, so I'm going to list in the amount. And what unit am I using with amounts? Is it gallons? Is it some pints? What is it specifically? And for this one, we are using fluid ounces as our unit here. So I'm going to go ahead and write in fluid ounces. We still want to be on a lookout for that unit because sometimes they do switch those in some more advanced problems, and I want to make sure we're just using the one that's given to us. Now, what's going to go down below? This is going to be the concentration. Now, the concentration is only able to track 1 single percent in this problem. And what is the concentration percent that we are very specifically tracking? Well, the problem has to tell us what that is. She's determined that the mixture of 24 fluid ounces contains 80% orange soda. So what is the percent that I am tracking in this problem? I am tracking orange soda. So I'm just going to write that in. Orange soda right here. Now notice, brand A is only 25% orange soda. Maybe the problem tells us brand A is 25% orange soda, 60% cream, 15% Sprite. Great. We're given a whole bunch of percentages here. What is the one and only percent that I am required to track in this problem? That is the percent orange soda. Any and every other percent that is not orange soda, we can just put a line through it, cross it off. It is completely irrelevant. It is completely useless information. We do not have the tools to track and find the percent of all of these other things in a problem. We are only going to be asked to find and work with one amount and one very particular percentage in these problems. If you are taking my class and you are looking at these types of problems, you can absolutely expect to see extra and completely useless information showing up in these problems. So be on the lookout for that and make sure that we have written out for ourselves what's the very specific percent that I am tracking for this problem. If you're not taking my class, if you're just finding this on YouTube, then I would fully expect that you're going to get problems with useless information eventually, but maybe not at the very beginning as you're starting with these mixture problems. Regardless, let's finish this setup and then get an equation written out and solve this thing. So, for brand A, what percent of brand A is orange soda? Well, that's just this 25%. These other, the 60 or the 15 amount, we don't care, because they aren't percentages. That's orange soda here. So brand A is 25% orange soda. Brand B is 100% orange soda. That's fantastic. And the result, or the thing, the ending mixture, is going to be, it looks like 80% orange soda. Okay, fantastic. Now I need to fill in the amounts inside here as well. What's the resulting amount? It's going to be 25 fluid ounces. Then how much am I going to have of brand A? How much of brand B? I've not been given any information that tells me the relationship between these two amounts. Something is double the other one, something's 5 less than half the other one. I haven't been given any information like that. So I'm going to have to use the I'm going to label one of these amounts, and then the other is going to be the leftover. So 24 minus A here. And again, you could reverse these and just have brand B be B, and then brand A is 24 minus B. It's your choice, but I'm just going to elect to use this one. Now I need to make an equation out of this. Last modification we need to do is with these percentages. I can't work with this as 25, 100, and 80. I need to convert these percentages into decimals. So 25% converts into 0.25, 100% converts into 1, and 80% converts into 0.80. From here, now I can make my general and starting equation with this. And now, here's the other part that's a little bit trickier and a little bit different from our previous problems. When we are working with concentrations, meaning we are tracking percentages of things, this is the other instance where we are going to have the amount times concentration plus amount times concentration equals amount times concentration as well. So if we have percent problems, we multiply all of the amounts with the concentrations together for each of these ones. So example 4 had this showing up. Example 5 we have here is the other example showing up where we always multiply the amount and the concentration together. So now that we have our initial setup, let's go through and let's solve this thing. So from here, we determine that we have 6.4 fluid ounces of brand A, and we have 17.6 fluid ounces, I should say, of brand B. Bringing everything back together at the very end, I have a quick summary of the stuff that we covered for today. We worked with setting up our mixture problems. We had our different strategies of reading through and identifying information. 2 different ways of setting up visuals for these things, either with tables or with buckets. Again, I'm perfectly happy with whichever one you would like to use. I personally prefer using the buckets, but the table is perfectly acceptable and it will work also. So making those visuals, labeling those things, being on the lookout for units, and then we set up some equations from there and solve that using all of the methods that we've learned previously. Remember that what we had with our first 3 problems, remember that we are only multiplying the amount and the value together for the 2 things mixing. The result, we are only using the value because we only have a total value that's presented to us. For examples 4 and 5, we've been given a rate that we are working with and a percent that we are working with. So for rates and percentages, the resulting bucket or the resulting column in a table, the amount and the rate or concentration multiplies together for these 2 types of problems. So hopefully that will give you a good starting place with a lot of these. I think it takes a bit of practice to get used to writing these things out and organizing them for yourself, but I do think it's worthwhile and very helpful. We do give those a try. So try those for yourself, and we'll see you in the next video.